Okay, class, you're welcome once again to Master Science Guide. We are still on the series of organic chemistry. Now, one core area I must tell you in order for you to be grounded in organic chemistry, all right? One area I would like to make known to you is the area of homologous series and functional group. See, I can bet 80% that I have seen a lot of students who have challenges with organic chemistry, and 80% of them, if not 90%, all right, they all don't understand this homologous series. I am telling you, if you can give your attention to today's class, your struggles in organic chemistry are ended. You have to pay close attention to homologous series and functional group. This is the basis to understand reactions in organic chemistry and to understand all other properties, all right, as regarding compounds and different homologous series in organic chemistry. All right, now let's come. What is homologous series? Homologous series is a group of family of compounds in which the members have the following, all right? In which the members have the following characteristics, okay? In which the members have the following characteristics. Number one, same general formula. So for you to say that two compounds are in the same homologous series, they must have what? The same general formula. I am not talking about molecular formula. For example, let's take the alkane as an homologous series. Please do well to watch this video to the end because I'll be dropping list of homologous series, all right, their general formula and their functional groups. So please stay tuned to the end of this video. All right, now let's say we take the alkane for example. Now methane is under the family of the alkane. Ethane is also under the family of the alkane, but then they have different molecular formula. Methane is written as CH4, ethane is written as what? C2H6. So they have different molecular formula, but we are not talking about the molecular formula. We are talking about what? The general formula. All right, the general formula. That is what we are talking about. So the general formula of both of them are both alkanes. So they have the same general formula. All right, they have the same GMF. Okay, same GMF. Now their GMF is what? CnH2n plus 2. So this is their general formula. So you see that you can get this from this and you can get this from this. So for you to say two compounds are in the same homologous series, they must have what? The same general formula. Now another thing again, they should have what? The same functional group. All right. So members of the same homologous series must have what? The same functional groups. Then another thing again, they should be prepared by the same general method. Now there's a general method of preparing alkanes, but then when you want to prepare a specific alkane, there's a more precise method that you use. All right, so I'm going to be dropping subsequent videos. Please do well to like, share and subscribe. All right, so now prepared by the same general method, and then each member homologue must differ by what? A CH2. Now the difference between this and this is CH2. Do you agree? Now let's prove it. This guy is CH4. This guy is C2H6. Now, what is this guy missing from this? Now, this one has 2 carbon. This one has 1. So it means this one is missing what? 1 carbon. This one has 4 hydrogen. This one has what? 6. It means that this one is missing what? 2 hydrogen. So the difference between this and this is what? CH2. So successive member in a series differ by what? CH2. So when they give you 2 compounds, all right, and those 2 compounds, they have the same functional group. Pay attention to that. They must have the same functional group. And then you now discover that the 2 of them, all right, they differ by a CH2. Now sometimes they can make the CH2 difference to be large, but then once you just observe that both of them have the same functional group, just know that they are in the same word, homologous series. So even if you are new to organic chemistry, you don't know organic chemistry before, I just put this question out to you. I just tell you that this guy CH3OH and this other guy C3H7OH. I just put this out to you and I ask, both of them, are they in the same homologous series? Now just pay attention to the functional group. This is a functional group. This is a functional group. Both of them has what? The same functional group. So your answer will simply be what? Yes. Now please don't worry. I'm going to drop video, all right, towards the end of this lesson. Once I'm done with this, now I am going to give you list of homologous family, all right, series, their general formula and their functional group. So I want you to memorize them, all right, when I drop them. All right, so to conclude with this, what is a functional group? We have been talking about a functional group. What is a functional group? Now watch this. Functional group is an atom, group of atoms or bond that determine the major chemical reaction of the series. So a functional group can be an atom. A functional group can be what? Group of atoms, just like this guy, OH. OH is a group of what? Atom, oxygen and what? Hydrogen. So atom or what? Group of what? Atom. Or it can even be what? A bond. A functional group can be what? A bond. Remember I talked about my previous video, Introduction to Organic Chemistry. If you have not seen that video, please do well to go back and check it. All right, so that is, I talked about single, double and what? Triple bond. So it can be a bond, but one thing is certain. All right, now what determines the chemical activity or the chemical reactivity of organic compound? It is what? The functional group. So please take note, the functional group determines what? The major chemical reaction. And then functional group is common to a series or family of compounds. So all homologous series have their what? Specific functional groups. So at this point, I will be dropping the different homologous series, their general formula and their functional groups. So these are the various homologous series, their general formula and their functional groups. So you look at the alkanes, general formula CnH2n plus 2, then the functional group is none. So alkanes do not have functional group. Please, this is even the reason why they are usually unreactive at room temperature. So alkanes are mostly not unreactive, all right? Alkanes are mostly unreactive. In fact, that is why they are called paraffins. The unreactive nature of the alkanes allows them to be given the name paraffins, which talks about what? Inertness, all right? Being inert. So please learn all of this, all right? Please, you have to take your time to know this and master this. Please, I am begging you, if you must be grounded and rooted in organic chemistry, you need to know this. So take your time to learn them and master them. So as we progress with our series of organic chemistry video lessons, you will begin to understand each and every step. So thank you very much for watching this video, and I'll see you in the next episode.